My name is Amir Hamaoui, and I am the Director of Customer Success and Operations here at Reconstruct. And I'm excited to be able to tell you a little bit about 3 different projects today related to college campus construction. All right. So let's jump right into it. So first thing is we're going to do a Q&A at the end. So if you do have any questions, please submit your questions in the chat box to the right, and we'll answer them at the end. And of course, you can pop anything in there as we go along through the presentation. So let me talk about myself a little bit. So I'm the Director of Customer Success. I've been in the kind of construction industry for 20 years. I started working at Bechtel as an engineer for kind of the first half of my career. And after that, I moved on to working for software companies in the digital construction space. I've been at Reconstruct for 2 years now, or almost 2 years. And it really kind of opened up my eyes to what reality capture and bringing in images just from projects can really add value to a particular project, kind of from the full project lifecycle, from the early design phases all the way through facility operations and maintenance. Before, I kind of lived in a purely digital world, meaning just BIM plus schedule, but really adding imagery and integrating it together really kind of closes the loop on a lot of the process. Today we're going to talk a little bit about campus construction problems. I went to the University of California, and we joked that UC stood for under construction. Basically, there's always something going on at campuses, and there's deadlines to open up classes, to open up sports stadiums. Deadlines and keeping the student population safe is always something that's very important. Of course, travel and logistics can be an issue because the campuses don't close, at least except maybe during COVID. But it's important to really have a good understanding of not just 1 or 2 projects on a campus, but the entire portfolio of projects that may be on a particular project. So who is Reconstruct? So Reconstruct is a visual command center that really ties together what I like to say like 3 different ingredients. One is reality capture, and that includes all forms of reality capture, whether they be from drones, 360 cameras, LiDAR, various other kind of reality capture devices that are coming to market. Design, that includes drawings and BIM. And then schedule, usually is CPM schedules, but tying in kind of the time element to these 3. Reconstruct combines all 3 of these ingredients essentially to answer one fundamental question over and over and over again, which is what is there versus what should be there. And we answer that question both from a production standpoint, meaning are things installed on time or are they delayed? And also from a quality perspective, meaning did they get placed in the right spot? Did they get inspected? Have they been gone through all the necessary quality checks? So the 3 kind of areas I'm going to be talking about today, and I'm going to give examples for each. One is, how do you model something that you don't have a model for? And with Reconstruct, you're able to do that by creating a, kind of an as-built reality model that then could be used kind of as a baseline to build a BIM model from that. But creating these as-built models used to be tedious. But with Reconstruct and a 360 camera, you can literally create these models, capture these sites within minutes, and then create these models within a very short period of time, generally within hours, and deliver that to all the stakeholders on a project. The second is talking a little bit about progress in 3D. So how do you keep track of construction progress? Is it on time? And so one is to take regular captures, but then what do you do with those captures by marking them up, communicating what issues may be, or just showing general work on a particular site because it's remote. You may never actually physically go to one of the sites that you are managing. And then the third one is quality control. And this can mean a lot of different things for sure. But quality control is essentially making sure that you deliver what you intend to be delivering. You can do that by verifying it against design, or just using your experts to review models remotely to understand that they have gone through the appropriate quality checks. So the first workflow I'm going to talk about is creating of as-built reality models. And the way that we do that is through doing a variety of reality capture. But the example that I'm going to talk about specifically has to do with 360 reality capture. And that's done with an off-the-shelf action sports camera. So here we are kind of looking at a drawing. A user will go out with a capture app and they will walk a site. Here you can see that they walked around the building, and from that, after taking the capture and having it automatically uploaded, you're able to jump into a 360 image and to take a look around, or to jump from image to image. And this is valid both indoors and outdoors. But that's not the only thing that we kind of deliver for that. Reconstruct doesn't just pin images to a drawing. What Reconstruct does is it creates a reality model. And here you'll see the underlying point cloud model that is generated from all the 360 images. And those spheres that you see, those are images that are taken from the 360 walk. Now, why do we do this? Well, we do it for a couple reasons, but one is to make the Reconstruct models measurable. And measurable means that you're able to take measurements for quantity takeoffs, for various design requirements or validation. Here you can see doing a measurement in 2D, kind of taking a square footage of that particular piece of equipment that was shown in the 360 image earlier. And here you can kind of take the void, kind of the open space around that. These materials may have certain requirements of offset from buildings. So you can use Reconstruct to measure kind of the size of certain things. Here's kind of another kind of demonstrating how you can take measurements in 3D for height, for width, for base, kind of general sloping to understand what slopes are, not necessarily for floor flatness, but for understanding kind of your general site conditions. Here we can go and do like a little inspection. Let's say that this facade needed to be cleaned. You can understand like how much surface area needs to be scrubbed. And you can also make notes and say, maybe this foliage needs to be cleared from the HVAC piping. These messages that you see, these markups, can be taken in the Reconstruct app. And then you can take a screenshot. You can save that to a pin, which is similar to issue management. Or you can immediately share that image via email or text so that people can receive it on site. Those pins can also be used to integrate with other work orders or issue management systems. Now we're just going to kind of back out here to show you the full model of this particular building that was built in the 50s. Here you can see the entire facade was captured, the corridors of the basement were captured, and the interior. Now, the entire time to walk this particular site took, I think, a total of about 25 minutes of 3 different captures. Here you can see the paths, the resulting drawing overlay, and the reality model. All right, the next topic I'll talk about is progress monitoring. So progress monitoring is making sure that your construction project is on time. If you have a schedule, you can update your schedule. If you just want to keep track of your project on a very basic level, you can just go out and do captures. Well, we just wrapped up working on a project with Texas A&M. They delivered a new facility that I believe had the grand opening last week. And I'm excited to kind of share a brief video of this particular project to kind of showcase how you can keep track of a project during its entire life cycle, from when they initially broke ground all the way through completion. So here you can see you're kind of navigating through the stadium, or sorry, not the stadium, through the basketball court area. It's not quite open yet. There's a few areas that they're working on. But this is not just images. Here you can start to see the BIM model that is placed in the same space as the reality model. In total, about 187 point clouds were created of this particular project. In this particular 360 image, we are navigating through time. You can see March 18th, March 10th. It's the orange timeline on the bottom, February 2nd. We're going back in time through the entire course of the project. This particular project took captures weekly of the first floor, the second floor, the roof, and the outside. And so in total, they captured at 64,000 square feet weekly in a matter of hours. And then those models were delivered regularly to the project and the project owners. This is another area of the project where you can see all of the HVAC, the temporary materials, all the equipment that was used to put together this, kind of shining facility, rec facility on this project. The next example I'm going to talk about is related to quality control. Now, quality control can mean a lot of different things to different people, but in general, projects will have a quality management plan. Within that, they're going to have various processes for quality assurance. And then there will also be quality control, kind of verifying that things are following the quality management and quality assurance plans. Now, Reconstruct brings in the design data with the reality data. And this overlay allows users to verify all sorts of aspects related to installation of quality. I'm going to show you three kind of different examples, starting off in the beginning of the project lifecycle. So what you see here is a point cloud model with the BIM model in the same space. This particular reality model was created from drone images. It's very typical in the early phases of a project to have drone imagery. Reconstruct at its foundation worked with drone imagery to start, but realized that once the building gets built, it's not practical or feasible to necessarily fly drones. And that's why Reconstruct developed the 360 capability that we have today. Here we are now back on the ground, taking a look at one of the foundations and the BIM model that will, the steel that will be fabricated at a certain point. It's very clear that you can have good alignment between reality and BIM to inspect various foundations. But the bottom left here, this is the navigation map. You're able to click on any one of these donuts to move to a different location. Here we have just kind of on the outskirts, you can see the purple slab that's going to be put in, but they are framing up the formwork for this particular slab, so you can see all the wood. So having these captures, you're able to do a lot of off-site QA of the early foundation works for the project. The next example is a little bit later in the project. We are now on the 5th floor, zooming in on the instrumentation lab. There's a lot of complexity with this particular project because they have a lot of lab material with a lot of MEP. Kind of focusing in just on what it looks like overhead. Here you see a transparent view of the BIM model and the reality model. And the pipe that just got circled, that pipe hasn't been installed yet, but it is visible in the BIM model. And this can be used to show offsite engineers and BIM coordinators what's actually being built at the particular facility. And so those views can be essentially used to improve the RFI process and to also do verification of particular models. Here you can see you can move around kind of in the BIM space and see all the cameras. The third example for quality control, we're kind of moving towards the end of the project now. This is the drawing of the roof. Again, the blue donuts are where the capture was taken. It's very easy to kind of navigate through the space. Now, the BIM model up on the roof has all the units for HVAC. You see the spheres where someone had walked and the elevated steel structure and various other components. But the BIM model doesn't show you everything, right? It doesn't show you the actual equipment and what actually got installed. And that's why having these blended views allow a more complete digital twin of your project. So the digital twin isn't just the BIM model and the various attributes, it's the images that are related to the final completion, because the BIM model doesn't necessarily show you everything. Here you can see, let's see, I'll pause it for a second. You see this pipe that's coming out of the roof. this is what the BIM model looks like, but the final installation requires additional components around the piping for weather protection and various other things. So having a more complete view of your project allows you to do better quality control. So that's pretty much what I got for you today.